Hello students, let us quickly revise our engineering physics syllabus in one short span of time and solve our model paper. Okay, now my engineering physics syllabus, relativistic mechanics, unit 1. Frame of reference means any set of reference frame that has been defined with the set of coordinate points as x, y, z, and t. Inertial frames are those frames when Newton's laws of motion hold good. Non-inertial, Newton's law do not hold good. Galilean transformation, x dash is equal to x minus vt. The experiment tried to prove the velocity of light in the velocity with the presence of ether as a medium, but it gave many negative results, and then the Galilean transformation equations underwent a change and Lorentz transformation equations came up, which are x dash is equal to x minus vt upon under root 1 minus v square by c square. The postulates of special theory of relativity are laws of physics are same in all frames of reference and velocity of light is a universal constant. Length contraction L equal to L naught upon under root 1 minus v square by c square. T equal to del t upon under root 1 minus v square by c square. Variation of mass with velocity m equal to m naught upon under root 1 minus v square by c square. Einstein's mass energy equation E equal to mc square. Continuity equation, displacement current, Maxwell's four equations, quantum theory, black body, Stephens, coherent sources, wedge-shaped film, Galilean transformation equations. The fringe width I found in my experiment was n is equal to del x by lambda equal to dv square upon c square by lambda. Lorentz transformation equations, x dash is equal to x minus ut upon under root 1 minus v square by c square. T dash is t minus vx c square upon under root 1 minus v square by c square. Length contraction L equal to L naught into under root 1 minus v square by c square. T equal to t naught upon under root 1 minus v square by c square. Relation between energy and momentum, E square is equal to P square C square plus M naught square C to the power of 4. Maxwell's four equation. First, Gauss law in magnetostatics, del dot B equal to 0. Second, Gauss law in electrostatics, divergence D equal to rho. Faraday's law of electromagnetic induction, del cross E equal to minus del B by del T. Ampere's circuital law, curl H is equal to J. Equation of continuity, divergence J plus del rho by del T. Maxwell's equations in differential form, del dot D equal to rho, del dot B equal to 0, del cross E equal to minus del B by del T, del cross H equal to J plus del D by del T. Integral form, integral D dot ds is equal to integral V rho dV. Integral SB dot ds is equal to 0. Integral E dot dl is equal to minus del by del t integral SB dot ds. Integrals H dot dl is equal to integral J plus del D by del T dot ds. Modified form of Ampere's circuital law. In free space, rho is equal to 0, J's current density is 0, charge is 0, Maxwell's equations reduce to del dot D 0, del dot E 0, del dot E equal to minus del B by del T, and del cross H is equal to del D by del T. For Poynting theorem, we find an expression which gives us integral V J dot E dV is equal to del by del T integral half E dot dH, that is energy due to electric field plus energy due to magnetic field H dot B plus integral E cross H ds, where E cross H is Poynting vector. The magnetic field, electric field del to the power of 2E is equal to minus mu naught epsilon naught del 2E by del T2. Radiation pressure, pressure is force upon area. Skin depth del equal to 1 upon attenuation constant. Electric field E upon H is equal to under root mu naught by epsilon naught is equal to approximately 377. Skin depth del is equal to under root 2 upon omega mu sigma, where omega is angular frequency, mu is a constant, and sigma is the conductivity. Quantum physics, E equal to sigma T to the power of 4 is Stephen's law, lambda m into T is Wien's law, E average energy of Planck's oscillator, E equal to h mu upon E to the power of h mu by kt minus 1. Lambda is h upon P, which is de Broglie wavelength. This formula can also be written in many other forms. Lambda equal to h upon under root 2 me. Lambda equal to h upon under root 2 mqv. Lambda equal to 12.28 under root v angstrom. Wave velocity into group velocity is equal to square of velocity of light. Schrodinger's equation is minus h bar square upon 2m del square plus v whole into phi equal to I h bar del phi by del t, and time independent is del 2 phi by del x2 plus 2m upon h bar square into E minus v phi equal to 0. Normalized condition of wave function is integral phi and or mod square of phi d tau equal to 1. For particle in one-dimensional well, phi is equal to under root 2 upon L sine n pi x by Ln, where n is 1, 2, 3, 4, etc. Compton shift del lambda is equal to h upon m naught c into 1 minus cos phi, where h upon m naught c is a constant which is known as Compton wavelength. Eigenvalues of energy En is equal to n square h square upon 8 ml square. Interference, the path difference due to thin film in reflected light is given by 2 mu t cos r plus lambda by 2. Path difference for wedge-shaped thin film is given by 2 mu t cos r plus theta plus lambda by 2. Wavelength of Newton ring experiment is given by dn plus p square minus dn square upon 4 pr. Intensity due to single slit is given by I is equal to a square into sine alpha by alpha whole square. Intensity due to n slit is given by I is equal to a square sine square alpha by alpha square into sine square n beta by sine square beta. Diffraction grating E plus D into sine theta is plus minus n lambda, where E plus D is my grating element. The dispersion d theta by d lambda is equal to 1 upon under root E plus D by n whole square minus lambda square. You can get this by differentiating the above expression. Resolving power is equal to lambda upon d lambda equal to n into E plus D sine theta by lambda. Laser and optical fiber, angle numerical aperture is under root n1 square minus n2 square. Population ratio for laser numerical n2 by n1 is equal to e to the power of minus e2 minus e1 upon kt, where k is Boltzmann constant. V number is equal to pi d upon lambda naught into under root n1 square minus n2 square. Number of modes n is equal to v square by 2. Number of decibels is equal to 10 log base 10 pi upon p naught, and alpha decibel b is equal to 10 upon L log base 10 pi upon p naught. Einstein's constants A equal to B 8 pi h mu cube upon c cube. Now, if I look at the previous paper, which was asked in AKTU exam, then I noticed that the question paper was of 100 marks and time given to me to solve the paper was 3 hours. If I keep 15 minutes aside for filling my copy, giving the biometric and other particulars regarding my examination, I am only getting 2 hours 45 minutes or 40 minutes to write this 100 mark paper. Let me see. It is consisting of section A, which is 20 marks, and in section A there are 6 questions, and every unit 2 questions have been asked. From first unit 2 questions are there, then from the second unit EMT 2 questions are there, then again from quantum 2 questions, from wave optics 2 questions, and fiber optics and laser 2 questions. Okay, now in section B I have got 3 into 10, 30 marks of question, and from each unit 1 question has been asked. From unit 1 relativity, unit 2 EMT, unit 3 quantum physics, unit 4 and unit 5. Numericals along with some definition is there in this section. Let me come to section C. Section C, the questions are of 10 marks and every unit has been given equal weightage for me to write a 10 mark answer. That means if I start solving this paper as per my time management is that if I start solving it from section C, I will probably fetch better marks compared to if I solve it in the reverse order of section A. Secondly, in my question paper, they have only given me few constants. They have given me rest mass of electron 9.1 into 10 to the power of 31 kg, speed of light 3 into 10 to the power of 8 meter per second, Planck's constant, and charge on electron. In case while solving this paper, I require any other constant, then I should be familiar with it of what other constant is required, because paper has only given me these constants. Okay, let me see. So what I will do in this 100 mark paper, where I am only getting 2 hours 40 or 30 minutes to start writing the paper, I will start from section C. And I know every unit has got equal weightage. So I will pick up my unit 5, which is laser and optical fiber. And I am noticing that last question usually is either ruby laser or helium neon laser. And it is of 10 marks. And this 10 mark breakage, I will get few marks for drawing the diagram, maybe 4 marks. Maybe 3 marks for my energy level diagram and few applications, etc. In case I have been given a numerical along with it, I will solve the same. Next question is on single mode and multi-mode optical fiber. That means it will be laser and optical fiber unit. That is unit 5. So I am getting a choice in the question. I have to discuss, answer any 3 of the following. Sorry, this is section B. Okay. So I am getting a choice So either I will pick up laser or I will pick up optical fiber. Next, I will pick up my section for what they are asking in 4, that is wave optics. Now, wave optics, this time maximum focus is going on interference in thin films of uniform thickness of light. So suppose this is 10 marks they have asked me. So I will first derive the formula of path difference and 2 mu t cos r plus lambda by 2. And conditions for maxima and minima, I remember for constructive or maximum intensity, effective path differences n lambda, minima or destructive interference 2n plus minus 1 lambda. And then I will come to my unit of quantum physics, that is de Broglie equation. Wavelength for particle is given by this expression if I am asked to derive the expression. So I know that E square is equal to P square plus M naught square C to the power of 4. I will put my value of E from Einstein's mass energy equation in terms of the potential, square on either side, take the terms of P on one side, B and Q on the other, and take the under root symbol. If I am asked Compton effect, I will explain the change in wavelength del lambda is equal to lambda upon H naught M naught C into 1 minus cos phi. Now, the third unit, that is electromagnetic theory, that is, second unit. I will derive Maxwell's equations in free space. For free space, I know charge is 0 and density is 0. So my favorite Maxwell's equations, I will only put rho 0 or J 0. And if I get a numerical on pointing theorem, I will remember S is equal to E cross H. Since electromagnetic wave is traveling in perpendicular directions, so angle between E and H is 90 degree, and therefore S is EH, and E upon H is approximately 377. And I will solve both the simultaneous equations. Quantum physics. Relativistic mechanics. If I get length contraction, I will write the formula L equal to L naught under root 1 minus V square by C square. And if I get a numerical on this, I will solve it easily. Einstein's mass energy relation, E equal to mc square. I know from Newton's law that force is rate of change of momentum. Also, momentum is mass into velocity. Work is momentum into velocity. I put these values, and using the formula of rest mass, m equal to m naught upon under root 1 minus v square by c square, I will differentiate and write the expression. Now, if I am given a numerical aperture and I have been given the refractive index of core and cladding, then I know that numerical aperture formula is under root n1 square minus n2 square, or if any other value is asked, I will put it in the formula. Grating A plus B sine theta is n lambda. Maxwell's equations in free space and velocity of light in vacuum is given by C is equal to 1 upon under root mu naught by epsilon naught. Massless particles and E equal to PC. That means first I will write the formula E square is equal to P square C square plus M naught square C to the power of 4. And for certain conditions where I am not taking variation of M, I can simply take square root and get the answer. Definitions of section A: population inversion, where the upper level has more electrons compared to the ground state. It is done in laser with the help of optical pumping or electric arc discharge. Acceptance angle and acceptance cone of optical fiber, the amount of light it is allowing to be leaking out of the fiber and the angle that is being contained by it. Dispersive power is the rate of change of angle of diffraction with change in wavelength. Necessary conditions for observing interference in light: monochromatic source of light, coherent sources, path difference. By the time I reach this stage of writing answers, already 2 hours will be over. So I have to write these 2-mark questions. I will not get more than 15 minutes to write 2-mark answers. So the answers should not be more than 2 or 3 lines. Suppose it is Compton effect. It is defined as the effect observed when X-rays or gamma rays are scattered on the material and increase in wavelength is observed. Planck's law describes the spectral density of electromagnetic radiation emitted by a black body in thermal equilibrium at given temperature T. Electrostatic energy density and magnetostatic energy density in electromagnetic waves is equal. I know from Poynting theorem this formula, and I can straight away show that it is equal. Equation of continuity, divergence J plus del rho by del T is 0. Massless particle is an elementary particle whose invariant mass is 0. Einstein's special theory of relativity is based on the fact that laws of physics are same in all inertial frames and speed of light is same for all observers independent of motion of source or observer. So before going for the exam, from unit 5, I will revise either ruby laser, helium neon laser, from optical fiber, the types of fibers, from wave optics, thin films, from diffraction, intensity due to single slit, from quantum, de Broglie and Compton, and from EMT, Maxwell's equations and Poynting theorem, and from relativistic mechanics, length contraction and Einstein's mass energy equivalence. Thank you.